Right, hello. Today we've got an absolutely beautiful integral. We've got the integral of x multiplied by the natural log of x raised to the power of n, where n is any natural number. So to do that, we're going to do by parts. We'll have the thing to differentiate as the natural log of x to the power of n, which when we differentiate, we'll get n natural log of x times n to the power of n minus 1, and the whole thing divided by the differential of log of x, which gives us 1 on x. Thing to integrate is just x. It's nice and easy, gives us x squared on 2. So sticking that all together, the nth integral will be u times v, x squared on 2, multiplied by the natural log of x to the power of n, take away u dash v. So the integral of n over x times by x squared on 2. So that's going to be nx on 2. And then still we have the natural log of x to the power of n minus 1 dx. And what we can do now then is if we move this n over 2 out of the front, we'll just move this x down so it doesn't look like it's flying. This integral is exactly the same as the one we were given, except the only difference, we've got n minus 1 instead of n. So we can rewrite that thing, if I just rewrite the first bit first, as I n minus 1. So now then, we're able to replace this thing with exactly what we've just written, but everywhere where we see an n, we write an n minus 1. So what we're going to have, we still have this same term, x squared on 2, natural log of x of n, minus n minus 2 lots of that same term again, x squared on 2, multiplied by the natural log of x, but now raised to the power of n minus 1, and take away n minus 1 over 2 of I n minus 2. So this is going to keep repeating itself and repeating itself. We'll just expand these brackets and see if we can see any patterns appearing. So we'll still have the first term, x squared on 2, natural log of x to the power of n, and then expanding these brackets, we'll have 2 squared on the bottom, nx squared on the top, natural log of x raised to the power of n minus 1. And for the second term, what we'll have is a plus. So the minus and the minus make a plus. We'll have n minus 1 over 2 squared, in to the minus 2. So we can start to see some pattern appearing, because this thing is going to give us again the same term out there, but with an n minus 2. So the pattern should be quite nice. So we'll try and write this as a series, as a summation. So what are we going to have? We'll have from r is 0 to n. We need the x squared on 2. We're going to have a natural log of n minus r because our power is decreasing. So r is basically like the minus 1 here. R will be 1. Here it's minus 0. See, for this one, we'd get a minus 2. We need to have it alternating between plus and minus. So we need a minus 1 to the power of r. We have on the bottom, I know we've already got a 2 over there. So this will now match up with our r. So imagine there's like, we've taken one of the 2's away. We still have 2 to the 1. Here again, we'll get a similar thing will pop out. So we're going to have 1 on 2 to the power of r. And then also, here we have n. Here we have n minus 1. So the way we write this pattern as it goes forward is n factorial on the top divided by n minus r factorial. Spot on. We'll take this over to the right hand side and do some rearranging and see what bits can come out the front. So spot on. Which bits don't get affected by r? Well, we have an x squared on 2. So that can come out the front. We have a log of n. So that can come out the front. Log of x to the power of n, sorry. There's an r there, so that's going to stay. An r there, so that'll stay. An r there, so that'll stay. And an n factorial as well, which we'll put on the top of this. So everything that's still affected by r will whack back inside. This is all gone. We have a log x to the minus r. We have a minus 1 to the r. And we have a half to the r. And a 1 over n minus r factorial. So lovely, we'll try and simplify this bit in the middle, make it a bit nicer to look at. N factorial x squared on 2 multiplied by the natural log of x to the power of n. All stay at the front. Still at the same summation, r is 0 up to n. And now then we can combine these two bits to make minus 2 to the minus r. And then we can actually combine it with this log as well. So we can move this bit over and have the natural log of x inside there. And the whole thing then will be divided by m minus r factorial. So lovely jubbly. Beautiful integral with a weird looking answer. But a nice summation, so we should be able to take in any value of n, and this will always give us the right answer, no matter what n is, as long as it's a natural number.